Hello everyone, I'm here with Efthymios. Hi Efthymios.
Hi Athanase, how are you doing?
Fine. Efthymios is an expert in soccer performance or football performance. Efthymios has been working in the United States, in European countries and in the Middle East. So he's here today to explain to us the change of direction protocol.
So change of direction in football is really important to avoid injuries and increase performance. We know that change of direction tests change completely from the traditional way to more contemporary way. So personally, I haven't been using any test of change of direction with time because I find it waste of my time. And we know that time is money and we don't want to spend it on things that don't make sense. So today I'm gonna show you a testing protocol with the Kinvent equipment that makes sense for me as professional and helps me prescribe training to my players in order to avoid injuries and increase performance. So having just a time in a change of direction test, we don't know exactly where the player lacks of maybe strength, power, or even range of motion. So I developed a testing protocol where we test everything. The protocol consists of three main areas: the mobility, range of motion, where we test internal and external rotation of the hips. Then we test strength with the groin squeeze and abductor squeeze in order to see if there are any imbalances between the two sides. And then we move on the power testing, where we do a skater jump, countermovement jump with a side jump, and a change of direction test. Everything on a 3D force place, where we're gonna get force and kinematic analysis of our players in all three axes of human movement.
Thank you, Efthymios. So now let's deep dive into three-axis analysis of change of direction. Efthymios, we have here the move, the range of motion sensor. How should we use it?
I mean, for the change of direction, I think it's really important to test the hip mobility and the range of motion.
We are going to install the move on your tibia and you are going to perform an internal and then external range of motion, and we will get everything in the app. Here we have installed the move on the tibia of Efthymios in the middle section of the tibia. Efthymios is now going to perform an active range of motion movement of his internal rotation. We are going to start with the left side. We are going to do one repetition. You are going to have 10 seconds to get to the max position. You can start whenever you want. Good. Let's now switch sides. Great. And here we see that Efthymios has 0.5% asymmetry between left and right. Now let's test Efthymios' external rotation. Ready?
Ready?
Go. Good job. Let's change sides. You have actually a bigger range of motion than average people. Good for you. Now, Efthymios, what do you want to measure?
So next, we need to measure groin strength. How can we do that?
We will use the K push. Do you have a squat rack?
Yep.
Okay, let's use the squat rack. We will use 2 K push to test on the same time left and right. Okay, we are going to install the push on the squat rack like this. Ready, Efthymios?
Ready.
You will squeeze as much as you can when I say so. Good job out there, Efthymios. Efthymios, you have a 3% deficit between left and right. Great job. So Efthymios, what's next?
So next is power. We have three tests, functional tests like skater jump. Skater jump is a good test to test our players' ability to move from one side to the other side. So next is the counter movement jump with a side jump. So a common test that we all do. So we're combining the vertical and the horizontal testing. Then before going to the last test, which is the actual change of direction.
Now let's check Efthymios' results. Efthymios, what do you think of your results? Let's start with peak force.
Yeah, peak force looks pretty much the same, 2% difference, which is not bad.
Peak force Y is the maximum force that the person will generate to the axis that they're gonna go. Now let's check your speed.
Yeah, which is really important on this test, because what we want to test is how fast the player is pushing off the ground.
And here you see that there is a very small difference between left and right, 2.9 meters per second and 2.8. I see that you have an 11% deficit between left and right. Actually, you're much faster going to the left, about 11%.
No, it's interesting to see that and how that correlates to strength. And if we see also the lateral RSI, we see the difference between the two sides.
The lateral RSI expresses explosiveness. It means how much contact time do I need to get to a specific speed. The bigger the RSI, the bigger the speed and the smaller the contact time.
Let's check the kinematics now.
Okay, so let's see the video with the synchronization of the force and the kinematics of the body.
Yeah, as you can see, it's obvious that I'm slower when I go on the right side.
We see here that your technique is pretty good. Once again, your knee is aligned with the force, which makes it very good for your quadriceps to be used. I think it's the same case on the other side. We see also that in this powerful moment, you really use your quadriceps as much as you could.
So if we go to the actual change of direction, we see how things correlate to each other. But we can see that when we go to the left side, I apply more force than when I go to the right side.
That's right, and this is what we saw also in the previous test. Now let's check your exit speed. We also have a very big difference between left and right of about 13%. That was the case also in the other movement.
So maybe we can say we can do one or the other test if we find that we have similar results, if we don't have the time. And again, if we go to the lateral RSI, we see that the left side is higher, faster than the right side with 50% difference.
That is a pretty big one. Let's see your kinematics.
Yeah, it would be interesting to see how that correlates with the kinematics.
We see Efthymios coming, he steps on, and then he goes. Here, what I see on my side, as a biomechanist, you start the movement pretty well, so we see very well that the force is aligned with your center of mass, your body has taken the right position, so you are going for it. But then, in the next frame, we see that your knee starts going inwards.
Yeah.
Okay.
Yeah.
That means that you won't use your quadriceps as much as you could.
Yeah.
Okay. And maybe there is an external torque onto your ACL. Then you continue the movement, and then you're gone. When you go to your left side, there is still a small angle. Okay. So maybe, my friend, you need to work on that.
Yeah, I think it's pretty obvious, and this is something you don't get when you do change of direction with just time. So this is really important information to have.
And this is where we talk about performance. So the lateral exit RSI could be a very good factor to follow up with performance, right? What else?
Yeah, for sure. And the other thing we can see from here is the kinematics and how we can avoid some injuries that we can get from this, like ACL injuries. The injury rate of ACL is going high. It's like 150% increase the last 10 years.
Wow, that's huge.
Yeah, it's huge.
Let's try to find the right tools to try to prevent those. Efthymi, thanks a lot for this video.
My pleasure.
And you guys, what are your thoughts on change of direction? Let us know what you think.